similar to group number 1. Okay.
Okay, so a lot of the questions.
Hello, come on, please.
A lot of the questions have already been answered, but we looked at it and observed it from a question angle. We've kind of put what we suspect some of the answers could be. So we've got, the first one is what you've already said. Why is the upper part of the implant shiny and below more of a dull colour? We suspect maybe it was something to do with marking, and also one of the other ideas, which I know now is wrong, is retention. It's smoother at the top and not smooth at the bottom, but it's not that.
It can be as well.
Can it be? Okay.
Because it's the surface, the treatment that is given to the surface that actually goes inside the bone. So it is a good point.
Yeah, and we'll come. It's a very good point, which we'll come on to later. So very good observation.
Okay. And then are the upper and lower part of the implant two different metals or a mix of titanium?
What do you reckon? So the comment is it two different metals on there stuck together? We'll just hold that. We'll talk about that.
And then the beveling inside the implant, looking inside it, there is almost this kind of almost like an octagon, isn't it, with a triangle beveling inside. And we were just talking over ideas what that could be. Does that help create a vacuum to keep the abutment in place, or is it a saliva stop?
Okay, and they're both excellent comments, and you're right in both of them. Inside there, it's actually tapered. It's tapered there, and it's what's called a Morse taper. I don't know whether they've spoken about, you've done about Morse tapers. There's a specific degrees, 2 to 6 degrees, where it's like, you imagine if you got two sheets of glass, little glass, and you put a bit of water between it. When you put it on there and slide them together, you can't put them off, can you? You can slide them, you can't put them off. So having this Morse taper creates that effect there, and it's a well-recognised engineering term, taper. And also, you're quite right, there's an octagon in there. So you've actually got an octagon providing some sort of mechanical direction there. So these are called, the parts that go on top are called synopters, and it's a synergy between the octagon and the Morse taper, which is an engineering feature they put on it to, so it secures in there properly and prevents any saliva, any micro leakage down there. Because if you get any crack down there, what happens is that it'll affect the tissue around it, and the implant won't osseointegrate, and you'll get what's called peri-implantitis, and then chances are this implant's going to have to be taken out because it's half falling out anyway. And we'll show some cases of that. Well done.
And then this is a really good question. It's talking about the size of the implant. Does it differ in terms of the load the tooth would take? So obviously posterior teeth would take more, have more of a load, or does that stay, is that like a standard implant size throughout the whole of the mouth?
No, there are different ones according to patient's needs. But yeah, we'll go through that as well. Really good question.
Okay. And then can it be custom made as well?
What, this?
Yes.
No, it can't be. But we've got enough implants for every patient.
And then there was actually a groove below the beveling as well. Vacuums come into it again. Some of the guys thought maybe that would form a vacuum below the bevel to further retain the abutment.
Yeah, and it doesn't actually create a vacuum, but what it does, it seals it, conically seals it, so that nothing can get down there.
Really good.
Brilliant, well done.